Well, hello and welcome, everyone. Welcome, PX Slip and Cat. Uh,
And Kat, she decided that she wanted to get some attention.
it's all good. It's all good. Well, welcome everyone. Welcome everyone, and good morning, afternoon, evening, whatever your time zone or sleep schedule may dictate. And yes, I was hearing myself in the background, and that always startles me. So I have fixed that. Let's see. So Uh, we will, as we usually do, spend some time chatting about things that we're interested in across the board, um, including NASA and some esports news from my end. That's our esports facility news, and then
We
the
should,
main topics, as the as the title suggests. Excuse me. I'm so last week I set up a router, a little simulated network, and did some router configurations. And my students are hopefully, at least, busily building the equivalent of that network over the next week.
one
Uh,
can only hope, can't
yeah,
they?
indeed. Um, and the the extension of that I want to do now. There are more things that I want to do with that network. We're going to make it more complex as time goes on. But the main thing I want to do today is see if I can remind myself how to set up IPv6 in the router operating systems, and get those and get those see if I can get those routers to work to work properly in with IPv6.
Is that ODG's new raid call? ODG raid and stuff. I like it.
ODG raid and stuff. Y3, hello ODG. Welcome,
We should
welcome.
probably before we jump into other topics, we should probably acknowledge the elephant in the room and essentially just say God save the
Yes,
Queen.
God say, well, yeah,
Yes,
Long live the king.
yeah, long live the king. Um,
Um,
so
yes,
ODG, I don't
uh,
know how much that matters to you personally, but
but
obviously an important moment
it
in
is,
your
yeah,
country's history.
yes. Uh, and as I recall, I've only found by a chat. As I recall, the queen was the queen's reign was 70 plus years, which makes her, I
Hmm.
think, the longest serving monarch.
Yeah. Someone
Um,
pointed out that her reign spanned Winston Churchill, born in 1880 something, to the most recent prime minister, born almost 101 years later.
hmm,
So,
indeed,
yeah, it's pretty wild.
that is, yeah, yeah, I mean, I can't remember. I mean, the queen has always been the queen, as far as throughout my life.
I think there are very few people alive who remember her
When,
father.
right. So yes,
Yeah, no, I said you do not have to be a royalist to admit that she was a pillar of sort of history in many ways, and it is sad to see um, someone sort of so groundbreaking pass.
yeah.
Anyway, I did not
Uh,
we did not go off on that tangent any particularly long.
but I think
Just
I
thought it
think
was
that was
worth acknowledging.
a very appropriate tangent. And as for those who don't know ODG, you might have guessed at this point that he is indeed from Britain, and more importantly, has a channel that have we did we did thank you, we did the shout
Oh,
out.
sorry.
I was
I got
watching
that. I
him.
got that shout out.
I was watching his channel for a little bit. Sorry, OG, I was lurking while I was trying to do something else. But I was watching his channel earlier, and he was. Let's see. When I jumped in, he was in Blender, I think, if I recognize the software, building an airplane. Then in Microsoft Flight Simulator, trying to fly it. And then he went over to Star Citizen, and that led into a half-hour debug session trying to find a phantom gamepad that was moving his cursor in. Yeah, it was. So if you haven't guessed, ODG does IT stuff. He does gaming, and equally importantly, his channel is a resource for mental health issues. And so if you get a chance, give him a follow and check out his stream. It's really good fun. And I mean, I don't think I've ever done that much low-level debugging in Windows. I mean, ODG was in the registry and a USB hacking tool and some other stuff. Um, well, that seems to describe my stream too. Um, yeah. So welcome, ODG, and the folks who came in with you. Much appreciated. All right. Aside from the sad news of the Queen's passing, a couple of things that I kind of stumbled across over the past week or so. Um, I've been watching a fascinating. I think it's a 26 episode YouTube series
Hmm.
from a group of folks who, quite by accident, were offered the loan of one of the Apollo guidance computers. It was one of the ones that was used during ground testing. It was never flown, to my knowledge, but it was man-rated, so it is in fact a replica of the ones that actually flew in the Apollo spacecraft and the lunar landing modules. And so this group is painstakingly trying to get this device to work. And of course, yeah, the memory is impressive. It's core memory, and it is at the time, this is probably one of the highest density electronics devices ever made. It's custom designed. It uses connectors that were only used in the Apollo program and the Polaris rockets, for all things. Do I have a picture of it? Let me check. Um, while I'm looking, there. While I'm looking, so it is fascinating to watch. As I said, I'm only about eight or nine videos into what is it? I think is a 26 video sequence, and this started 4 years ago. Um, the uh, they're painstakingly testing each. Apparently, I mean, this thing is basically set in a heap of electronic waste material. I mean, the gentleman who found this thing bought 2 tons of electronic materials in a lot in an auction, and as he was going through it, found this thing. So it the core memory is not working, and so they were so they're I think their plan is to basically use one of the use. I mean, since this is a ground test unit, it has some ability to feed memory information from externally. I think that's what they were going to do. Um, but yeah, it's just amazing the tech that's in there, given the date. They got the thing. They got some of the not the central processor in the episodes I've watched. It has some discrete units that handle the alarm systems. So they actually uh, turned down the input, the operating voltage, and triggered the infamous main bus B undervolt alarm that started the sequence of Apollo 13 diagnostics. So it's a fascinating series. Let me see. Let me see. So I've got. See if I've got. So let me see. This guy here. Um, So let me switch to this. Hello? Oh, that's not what I wanted. There we go. So yeah, I couldn't find the right button. So this is what they call the rope memory, and let's see if I can get. Yeah, so this is the ROM. This is the ROM for the guidance computer. So yeah, I could yeah, and again they did an interesting video where they took some IBM core memory and oh, and this is what the guidance computer looks like right there. It's actually two halves, and these are plug-in modules, so it's very similar to what in concept to what we do today, but executed completely differently. So this is but this is the ROM module that plugs into it's under this square plate in the back. There's a place for the core ROM, and then one of these slots I think is the actual dynamic memory, which is constructed a little bit differently, but it's not dissimilar to that. But I wanted to see if they had the. Is this the? This is a Wikipedia entry, so I have no idea if this is any good or not. No, that's the same image as the core rope. The problem is the actual memory module is sealed, so there may not be any. So this at least gives some idea. I mean, this is what this looks like. This is and you'd have to. So if you see this on stream, so let's see how far I can if I can zoom in then. So, oops, there we go. I can't drive today. Those darker things that you can see in the image, those are ferrite rings. And then I mean, like I said, ODG is right. I mean, we could do an entire stream just on. We can do an entire stream just on on how this stuff works, but it's fascinating. So anyway, I'm not going to spend a ton of time on this, but I just want to point out. So I think once I've watched the entire series, I might just do a stream. We talked a bit about the guidance computer. I need to do a bit of research on that. It's really cool. Yeah, I do that too, ODG. I try to drag instead of finding the scroll bar. All right. Okay. So that's really cool. I've been spending way more time than I should probably watching that, but it's such good fun. Totally different topic, and then we'll return to space topics for a little bit, talking about Artemis before we get going on other things. I had some interesting conversations. So those of you who've been here on and off may remember that I'm involved with Ohio University's esports facility, and we have competitive teams in 4 different games. In the fall semester, which is ongoing now, we have Rocket League teams and Valorant teams. And in the spring, we'll have League of Legends teams and Overwatch teams. The team started competition last week. So last week and this week was the second week of competition. We're getting ready to start official broadcasts in another couple of weeks. It's weird. I mean, we were basically held back by it wasn't just even months after we got the computers for the facility. it took forever to just get even small parts, cables, small amplifiers, power supplies. I mean, just everything was a struggle. So we're a little bit behind, but and of course, then when we're in the summer, we didn't really have student labor, so it's going to take us another week or two to get geared up to actually do official broadcasts. But we're very close. The also, and this is kind of an on-campus kind of fun thing. Starting next week, the facility is going to the esports our esports facility has kind of a competition space that's reserved for the teams. They can practice there, and of course they're now playing their games in our facility. The competing teams do not travel, so everyone plays out of their own facility. But the but the teams I think are really enjoying playing together in the facility, and that's it's really nice to see. But the starting the other half of the space is about a 30 plus computer lounge that is just meant for open gameplay. It's also available to students who want to practice and maybe try out for the teams. We have our A teams, our varsity teams are the ones competing against other colleges, but we have B teams that basically they play you know just kind of casual tournaments and those sorts of things. And play scrimmage games against the A teams and so on. It's a and so in the morning, that facility can be booked like any other educational space. So anywhere from, I think, 7:30 is normally the start of a school day to 2 p.m. Classes, it requires permission of the facilities director, but classes could meet in that space if they have an appropriate use case. And in fact, we're trying to drum up business in the sense of saying, and I think I've mentioned this on stream before. And in fact, there is someone on campus who is planning to use one of the Assassin's Creed games to teach history. History and anthropology, because they are quite accurate, actually, historically accurate. But we want to see more of that, more of that sort of use of actual games in various forms of education as appropriate. So in the morning, early afternoon, the facility is going to be used for classroom activities, and then from 2 o'clock to 10 o'clock in the evening, the facilities is open to the campus community, so people can walk in, and it's like an internet cafe essentially. And so we think that's going to be I think it's going to be popular, and it's going to be fun. So that's opening next week. So I was in a couple of meetings this week about the broadcasting aspect, and that gets kind of interesting because we have a facility where our broadcasting environment is, of course, co-located with with where the teams are sitting, and so in most games, that means we have to be cautious that we don't allow the teams to accidentally see the broadcast if it uses God view, right? If it uses observer mode, where you can see past the fog of war. And so in the 4 games we're playing, Valorant, that will be an issue, right? Because it's a shooter. Rocket League, nobody cares, because you can see the entire playing field anyway as an individual player. League of Legends is a big deal because of the fog of war, and Overwatch, same sort of thing. Mm-hmm. There's that is actually not out of the question, ODG. That's I'm going to talk to engineers about that. So we have 2 issues, right? the collegiate association that is basically organizing the league, and it's not NCAA. For those of you in the in the U.S., this is not NCAA, which is like the football, basketball, soccer kind of collegiate sports, because they're way too restrictive and way too sort of rigid. So nobody wanted to get under that umbrella. It didn't make any sense. But there's an organization that oversees this league, and I think it makes sense. Or basically, across the board mandated, any game that's being streamed has to be delayed by 3 minutes.
Hmm.
I was just thinking about that. So, somebody has built a programmable display, and somebody built a simulated hard drive in Minecraft, which I thought was pretty impressive. So yeah, so our league requires 3 minute delays, which is reasonable across all games. And so in 3 of the 4 games, everything except league, we'll insert the delay, and I'll explain why that doesn't apply to league in a second. We'll insert the delay, but that means that the announcers are going to be talking about the game as the players are playing it. And so we're trying to work through what's appropriate, right? So none of our displays in the facility, for example, will show the actual match the way we're broadcasting it. Although we are able to do that, we're not going to do that for matches that we're delaying. That's sort of it's kind of a weird situation because obviously this is being done in big tournaments, but in those cases, if you watch carefully, the teams are always in sort of an enclosed, glass enclosed booth, so that insulates them from hearing the announcements and maybe reacting to things that they shouldn't know about, right? Which is always the issue. This is really more of a restriction of what we can actually have on our displays in the facility as things are going on. But League of Legends, at least as we understand it right now, is uniquely complicated for us, because in League of Legends you go into the game as an observer. There's no broadcast slot per se. You go in as an observer or a spectator, and the League of Legends servers delay the game feed to spectators by 3 minutes. You think about that for a second. Our announcer will comment on plays that the players in the room played 3 minutes ago. I'm going to stop here and let that sink in. That's really kind of ugly.
How does LCS do it?
They must have special broadcaster slots
special.
You probably have to be an authorized, verified broadcaster to be able to hook in there. Unless Sorry,
go ahead.
I said unless they're finessing it the way we're planning to. But you go ahead and.
Well, I say I know in Dota it's a sort of and that it probably is the same architecture, but in Dota when you form a custom lobby, there is in fact an option to add essentially viewers that watch the live stream as opposed to spectator stream.
Correct.
Which is similarly, I don't think it's as aggressively delayed, but.
Yeah, I think Dota may even have designated broadcaster slots in custom lobbies. Yeah.
In custom lobbies, there are broadcaster slots.
And so the way the way it's been described to me, League doesn't have that. And that at least nothing that you can access as a normal human being. without leagues. I do. We're reaching out to the companies that manage tournaments to find out what the magic is, because we would prefer not to have to deal with that. But otherwise we have to do the commentary back in our broadcast booth, because the teams will be done, and we need to give the announcer, basically the ability to finish the broadcast, and then we'll assemble the post game show. But um, uh, it really is that's really a little bit of a tricky. That was tricky. That was tricky. Um, I think in one of the games, can't remember. There's some thought about going in as in basically captain's mode, so we basically just watch one team and not the other, which makes it a lot less,
Yeah.
not in league, but which I don't think it exists in league either. So so we're figuring that kind of stuff out. It's quite interesting. So these are not technical issues. They're basically management issues, and that quickly gets out of my realm of expertise. So we're going to start bringing in people that understand sports broadcasting, and we'll kind of figure it out. If you think about it, the only place that I can think of where real world, where physical sports are doing this, or used to do this, I don't know that those broadcasts have been shown in a long time. Poker.
Yeah.
The World Series of Poker ran on a 2 or 3 minute delay, um, for the obvious reasons. But so that's but yeah, we can handle if we handle the delay, because we finish our broadcast and then there's kind of a 3 minute sort of dead period where we have to let the stream catch up to real life, and then we launch our post game show, which is that's not a big deal. But league is really going to be a challenge. So anyway, yeah.
Oh, so that's intense. Kind of like I'm trying to come up with like how would I.
And if you find something as far as how do the professional League of Legends leagues actually handle broadcasting, we're trying to find out. Because look, there has to be a behind the scenes. I said I don't know if they use the same concept of custom lobbies that Dota does or not. They have
There
to in order to organize
there
and organize
yeah.
tournaments.
Yeah, so there are. I'm looking at their API documentation right now. There are, in fact, some some ways to create tournaments, essentially, which allow you to have custom lobbies. Um, what I don't know is
Yeah.
whether or not that gives you any help as
If you,
far
yeah, right. If
as
so, yeah, so, I'm assuming that they're using custom lobbies to in
yeah.
the tournaments. But what I don't know is can you put someone in a custom lobby who gets the
Hmm.
live feed in God view,
Yeah.
or not? And it sounds like that is at least not an option you can choose. Sort of click a button and say, I want this slot to have the real feed. Apparently that the league client doesn't allow that. Now I'm assuming that for big
There's
tournaments
probably
that there's probably like a behind the scenes setting that they can that the back end can set to create that, but I don't think you can do it on your own in a custom lobby. So that's going to be an interesting. Fortunately, that's not until spring semester, so we'll do some research on that and see if we can overcome that and then figure things out. Ugh. All right. What else?
there's gotta be a way. I'm just not. I'm curious. So
Yeah,
you
if
can
I
continue
said
on. I'm just
yeah,
being
if you
stubborn.
stumble across something, I'm all ears, as they say, all ears. Um, the of course the thing I was kind of is that having just talked about the Apollo guidance computer. I'd be remiss if I didn't kind of follow the Artemis story, which continues to be about space is hard and hydrogen is difficult to work with. The most recent launch attempt uh, didn't even get as far as the previous one, because they could not get they couldn't stop a leak in the fueling line, in the hydrogen fueling line. Um, Now this got a little confusing. I don't know when their next launch attempt is, but I don't think it's until October. There's someone thought they'd seen an announcement they were trying to do something next week, and I don't think they can. Um, here so I was trying to kind of figure out, if they're going to have to go back to the assembly building anyway, and I'll explain in a minute why that's the case. Then why wouldn't they go there and have a much cleaner environment, easier environment to work on the fuel on the seals for the fueling attachments? Problem is that the only place you can actually test this under load is on the launch pad. The assembly building doesn't have a liquid hydrogen feed. That you can get the liquid hydrogen, liquid oxygen only on the launch pad. So right now and it's going to be up near the top of the rocket. So it's kind of interesting. So they're building basically they're installing a small enclosure, temporary enclosure, so they have a weatherproof place to take the seal apart and replace it. The advantage being that as soon as they do that, they can run a fueling test on the pad and determine whether they've actually fixed this leak or not. So that's why I think why they're staying on the pad. The problem is they can't then launch. The problem is that they've been on the pad for too long, and the Artemis, the space launch system lift rocket, contains, as all of these things have to, a launch abort system, and that's basically exists to make sure that in an instance where the launch goes where something goes wrong with the rocket, two things are supposed to happen. The capsule has an escape system, so it has a small rocket at the very top that, in an emergency, will pull the capsule away from the rest of the rocket, and the rocket itself has a self-destruct system essentially. It can be safely terminated if we lose control of the rocket, so it doesn't spiral into a populated area while full of fuel. And the requirement is that the certification of that launch abort system, because of batteries, and it just has to be independent of everything else. It has its own batteries. The certification of that is only good for 25 days, and they've been on the pad for too long. So they're going to have to go in to the assembly building and reset the batteries and get them recertified and then move back out. And that's a long, just because they move so slowly. That's it's a day-long drive back each way, at least. We'll see what they do next, but yeah, I think this is not entirely unexpected. I mean, I'm a little surprised that the problem is in this area, because we've done hydrogen fueling for a very long time, and of course SpaceX uses it as well. But hydrogen is very finicky. The molecules are very, very small, and so it requires a very very careful seal, and stuff happens. So it is perfectly possible that they have to ultimately re-engineer what material they use, or what grease they use, or or what pressure level, how much pressure is on the fitting. Because these are quick connect, quick disconnect fittings, right? Because just like with the shuttle, because this is liquid fuel at a very low temperature, it basically boils off as the rocket sits. So you have to top the tanks off continuously until just before launch, and then you pop the quick disconnects off as the engines fire. So these are complicated connectors. This is not a regular kind of fueling hose that you might use in other things. So yeah, that's something we'll just have to follow. And yeah, so we'll see where this is at next week when we have this stream. Anything to add from your end on this?
No,
Anything else
I
you see?
hadn't been paying attention. I hadn't been paying attention
Yeah.
to space things recently.
Yeah.
Too much else going on in my life.
Too much else going on. All right. Well, let me pop this. Let me pop this this simulation back up. For those of you that were here last week, you'll recognize it. If not, I'll give a quick rundown. So this is and this is on the outside a virtual machine running in the data center that my department at the university operates. Each of my students has an instance of this exact same virtual machine, and the program I'm running is something called GNS3, which is a network simulator. Actually, to be honest, it's probably more appropriately a network emulator. The individual, so all the icons on this canvas represent actual devices. So this guy here, bottom left, is a container running a. I keep forgetting. I need to at some point look up what the base is for that. But it's a container running one of the Linux distros, stripped down to make it as lightweight and fast booting as possible. So it's a basic Linux command line environment. The switches are basically unmanaged, simulated unmanaged Ethernet switches, and each of the kind of amber, orange looking V's here represent a small virtual machine running a VyOS router instance. So these are software routers. But so all of these are not running simulated code. These are actual duplicates that run the actual code you would run on a hardware device. We catch up and chat here real quick. ODG, it is on the outside, and it is not hard. The question is not how easy it is to replace. It is not hard, but you have to, if you don't do it on the pad, you can replace it and have no idea if you fixed it or not, because the only way to know if it's going to leak is to actually run liquid hydrogen through it, and the only place where they actually have large amounts of liquid hydrogen they can pump through there and watch for leak under the underloading condition, under fueling conditions, is actually on the pad. So it's high up. It's in a place where there's not normally like a gantry. There's not a walkway for you to get to. It's not the only place where there's a walkway is where you would get into the capsule. In fact, we bring it back up here. I think I still have it. And so if we look at so this, I think, you can see these various umbilicals coming across, and I don't know which one is the problem one. But these are support structures that, except for one, they're not actual walkways. And so there, as you can see, there's nothing really at the edge of the rocket that that provides cover or anything like that. And you don't want to take, this is in Florida in the U.S. It rains all the time in the summer, so you don't want to take the seal apart in the rain. So they have to install basically an enclosure that just keeps the elements out. But that's that. So it's not. I don't think it's hard to replace. The things they have to basically install is, so they've installed something to make it to keep that area dry, do the replacement, then take that back out because it isn't part of the normal operations, and then go through a fueling test. Basically load the spacecraft with fuel and watch for leaks. So it's just time consuming. I don't think it's not hard. I do not know why, but the launch abort system requires that they take the entire assembly back to the assembly building to reset. And I don't know what the details are on that, but that's why that's going on. Okay, so with that, setting the stage here a little bit. So in last week's episode, I didn't quite finish. I haven't set up all the. I don't think I ever configured all of the entire network, but I got most of it done. I think I can tell by looking. Let's look here. Actually, it's kind of nice that it actually shows me that 0 is connected. Connected. But it does. It's not gonna show. It doesn't show me what I have configured, so I'm gonna have to bring up the console here. So this is the device over on this side. Yeah, so on the I set this edge network up on the left-hand side, but if you look at this output, I've only configured the path from this router back into the network, but not the path to the actual network. I might do that today. I might not. My main goal is to actually configure so the routers to talk IPv6 with each other, and see if I can get that to work. So I'm going to start there, and then we'll see if there's if I find if I want to fill in some more stuff, I might do that. But the focus really is IPv6 right now, and I'm obviously going to have to fill these in at some point to do full-fledged testing. But for now, that we're good enough. Right. So I might as well pick on these two routers here for now. So what I want to do is this link here from this is number 4 to number 5. So I want to set it up with an IPv6 address. Now that to do that, I'm going to have to figure out what address space I want to use. This is an isolated network. I don't have public IP space that I can legally use, and I want to get my students used to that. In IPv4, we have an RFC, a standards document that sets aside certain address ranges that anyone can use in an isolated network anytime. And most of us have run into 192.168.something. If you look at the addresses in your home network, that's one of those reserved address spaces that anyone can use. I'm using the 10.0/8 address space that is similarly set aside. And you might not at this point say, but my network isn't isolated. How can I use those addresses when I'm connected to the internet? And that is a discussion for an entirely new day, another entirely different day, because those addresses are not what the outside world sees. Your router translates those. Yes, Y3, that is RFC 1918. That sets aside those address blocks. And so if you use those address blocks and we use them extensively, because if I wanted to get the 20 or 30 addresses I need for my house, I could not get them. They just don't exist. IPv4 doesn't have enough addresses. That's why we have IPv6 in the first place. So in our current usage, my house uses one of these set aside blocks. I use 10.0/8 in my house as well. But any packet that leaves my house, my router actually reaches in, changes the addresses to basically replaces my internal address with a one external address, and does some other shenanigans to make that all work. That's a discussion for another day. That is a drawn out discussion. Network address translators are evil, but they're also necessary because we waited way too long. And even though we have IPv6, the vast majority of traffic in the world is still using IPv4, except that's probably not. I haven't looked at traffic numbers. That may not be fair. Because a lot of IPv6 traffic is actually happening in mobile networks. Most of our cell phones use IPv6 whenever they can. In Windows, if you turn off or uninstall IPv6, half the stuff in the operating system will break, because Microsoft internally uses IPv6 all over the place, but you don't notice it. Right? So normally for IPv6, it would be trivial to go and get a block of addresses. Obviously, I wouldn't want to do it for a little simulation like this, but in IPv6 you can get addresses just fine. Y3, so he's saying my ISP is weird. I got a static public IP at my router, but my first hop is another public IP, then a 10, and then another public IP, and I'm on the internet. What you're seeing is twofold. First of all, one of the ISPs in the chain that leads to quote unquote the internet is using one of those private blocks, just internally connect their routers, and they were careless and didn't filter or chose not to filter packets that report one of those private addresses as the source, right? So I'm assuming you were doing something like traceroute to get that information in the first place. Traceroute works by deliberately triggering basically an error message, and the error message is sent by the router that detects the error, it is perfect. So it's a trade-off, right? So that if that router is part of an internal network, and it uses where it gets the packet has one of those private addresses, the error message will have that private address as the source. Since the error message isn't something you're going to end up replying to, it makes sense that you get that information. Yeah. But in that case, your router, if in a true with a carrier grade NAT setup, normally your router would not have a public IP. It would have another. So I've seen this, for example, Blue did this at one of the satellite providers. And so if you check, so you had your IP, the external IP, the outside IP on your router was a net 10 address, and then eventually that got translated a second time. That so it's but ISPs and corporate data centers, lots of places use these private address spaces. Just on cases like this where it's isolated. You have things that never talk to each other. Pixlip in a lot of the cloud implementations you're doing. If you have containers that talk to each other that are in the backend, like database servers and such, as I
Hmm.
recall, a lot of times those are sitting on internal networks in the cloud service, and in IPv4 world, they almost always use private address space for that. So
So
net 10 is a lot of what I'm seeing in those backend spaces.
yeah, so almost every example for an AWS VPC starts with declaring the CIDR blocking that you're going to use as 10.00.16,
Right.
and then every subnet within there is at /24.
Yeah.
Basically, you give yourself whatever it is, 2 to the 16th uh, addresses for your
Addresses. Yeah.
VPC and 2 to the 8th for your for each individual subnet
Right.
within it.
Right. And in that case, and it's a Y3. That's um, that's again sort of obviously why waste public address space, especially IPv4 is very very rare. But in that case, even more importantly, those are really internal networks. Um, those are really internal networks with that the only purpose for those networks is to allow the containers to talk to each other, allow the Kubernetes controller to talk to the containers, and so on. And you use routable addresses only where you actually interface with the customers. We interface with the internet. Yeah. All right. So what about IPv6, right? Because uh, the big difference here is that with IPv4 we have 32-bit addresses. We have about four and change billion addresses available, which is like one address for every two people on Earth these days, which is obviously not enough. Uh, so we basically we were destined to run out of IPv4 space. Now, in defense of the original designers, IP was never intended to live this long in that version. And so 20 years ago, IPv6 was designed and finalized, and it took forever to get adopted. And as you said in your message and in chat, that a lot of small ISPs haven't implemented because it's hard. Because now you're dealing with two protocols. You're getting customer calls that require better train. You get more calls because it's confusing. It works a little bit differently. Lots of reasons in customer facing environments to shy away from deploying IPv6, and that's causing some of the problems with that we're having. So IPv6, of course, is very different. It uses 128-bit addresses, which generates such a large increase in addresses that right now we're basically creating networks using a standard end user IPv6 network uses 64 bits to identify the network, which leaves 64 bits to identify individual devices, which is essentially infinite for all practical purposes. And so where the IPv4 internet has something like 4 billion addresses, IPv6 basically has 4 billion internets worth of networks, not addresses, with each network being infinite size. So at this point, we have basically an internet. So we have basically, 4 billion. We basically have 4 billion networks for every 2 people on Earth, right? So technically, each one of us can sort of claim like a couple billion networks, and each network is infinitely large. So there's no need for these translation shenanigans. So the question is, if I have an isolated network like this, what address space do I use? Right? Do I actually have to go and get a block that I can then use to my heart's content? The answer is probably not, because while the address space is infinite for all practical purposes, we want to keep the global routing tables manageable, and so we don't want to hand out address allocations that are not well organized and not designed to keep global routing tables down. So the idea is that to get an address block, you should really be served by an ISP, and the traffic is routed to that block from that ISP. So if you're playing around with isolated networks, or networks that we're trying to set things up that aren't meant to interact with the network just yet, with the whole network just yet, like my simulation here, I still need something to work that. And so there is an interesting concept in an IPv6 that I want to try out and see if I can get that to work in these operating systems. And that is, let me pull up that site. And that is a concept. I'm going to go to the top. I was reading this, and so of course I didn't believe it at the top. It's a concept called unique local IPv6 unicast addresses. It's a mouthful. And they're typically referred to as ULAs, unique local addresses. They should really be considered almost unique or pseudo-unique. That's like random numbers or pseudo-random numbers. And so let me explain what these are. There's a standard prefix that has been assigned to, just like in RFC 1918, there's a standard prefix that defines addresses that are not to be handed out in the global address assignment system. These addresses you and I can use freely, with a twist. We are supposed to make a concerted effort to keep them make it very likely that if for some reason my corporate so if I use these in the back end like we use in that 10 now in our cloud services, and I want to merge two of those cloud service networks, right now, Peerslip, if you had two separate applications and you pick the same 10 dot block for each of those applications, if for some reason you decide you need to connect them, now you can't, because the addresses conflict. If I follow the prescription in this RFC, I have a very high probability that I can connect those networks, and all the everything will still work because the prefixes won't collide. So the way that's done is the block set aside is FC00/7. So the first what's a C? I'm trying to remember. BCC is 12. It's 8 and 4. Okay, so I'm just trying to figure out the bit pattern. So the first 7 bits in here are fixed, and C. I said C is is the first two bits in the so it's like 6 1 bits and a 0, I think, is if I'm doing this on the fly correctly, that are set at the beginning. Right, so that identifies. So anything that starts with that bit pattern is part of this allocation. The next bit is and this is something. It's kind of weird. The next bit is, for all practical purposes, always 1. So you end up with FD00/8 as the prefix. Originally there was the internet draft that led to this RFC specified that there were 2 types of unique local addresses. They envisioned basically an entity much like the entity that assigns MAC addresses. You could basically, instead of asking for a global address space, you could ask for a ULA prefix. And so you'd be assigned a guaranteed unique prefix, ULA prefix. That entity doesn't exist. It's never been created. It's never been standardized. So the only version of these that exist are the ones that create their prefix locally, so that L bit is always supposed to be 1 because there's no the other ones just don't exist. There's no entity that is authorized to hand them out. And so the trick here is these 40 bits here. What's called the global ID in this system. You are supposed to use a pseudo-random algorithm to generate these in such a way that it is highly likely that nobody else will have that same prefix. 40 bits. Remember, that is more bits than the entire addresses in the internet. So there's a very large number of these possible. And it's kind of interesting. I think what I was reading earlier, there's an analysis of how likely it is that in my example, if two applications needed to be merged, how likely is it that if you follow the rules that you would end up saying, oh my God, by pure accident, both have the same prefix from global ID. It should be very unlikely. So this is a lot more complicated around RFC 1918, right? And there you just basically look at which of the 3 blocks I want to use, and everybody uses the same addresses. That's not true here, because I have so it's a big address space. Now, just to finish this thought here. So we have 8 bits that are fixed. We pick another 40 bits, so we create a 48-bit prefix. That means, remember, I said the largest prefix that is allowed in end-user networks is a /64. So that means our subnet ID in here that fills in the 16 bits long. That gets us to 64-bit 64, and the remaining 64 bits identify the host in the network. That means I have 16 bits, or about 65,000 networks. So if I pick one of these global IDs, I can create 65,000 networks of essentially unlimited size, which in most applications should be plenty, right? So this is not, so it's kind of interesting. So what they did is, and this is what I was looking at earlier. No, this was the analysis of how long they should make these. So the global IDs. So this is what they envision. You're supposed to take a 64 bits derived from the current time. You're supposed to take another 64 bits that are tied to the hardware you happen to be on when you do this. It could be your Ethernet address converted to 64 bits. There's an algorithm for that, or a serial number, or something like that. You then do a SHA-1 digest, which generates 160 bits. It's a hash function. and then you take the lowest order 40 bits of that and making a global ID. So you basically taken some unique bits of information and turn them into used a hash function to process those into something that doesn't accidentally divulge like your hardware address or something like that. And then you take not all of the hash to generate those 40 bits. So this was kind of interesting. So if you do this properly, let's say if you're if you're using a different system-specific identifier for each of the prefixes you create for your organization, if you're then trying to connect two of those randomly created networks together, you have a probability of about 2 to the minus 12. 1 and 2 to the 12 instances, you have a collision. That's pretty acceptable. Right? And so even if you connect 10,000 of these networks together, you still have a less than 1 in 100,000 chance that 2 of those 10,000 prefixes will be the same. So the idea is that you create in a scenario where it's where once you've built a network, you can and you need to, for some reason, an internal network, and you have for some reason have to connect it to another one that uses that same scheme. You're you okay?
Yeah, sorry. No, that was just an intense sneeze.
Yeah. So
Excuse me.
your chances of having those two having those work properly are very, very high. So that's why they're doing this. Now, why would you use this? Again, it makes for a very stable addressing for things that just need to talk to each other internally in a network. These are not exclusive. It's not either or, right? If I use RFC 1918 private IP addresses, that I can't also run public addresses. But in IPv6, every network interface can have multiple addresses. So I can very easily put this on, and then when I'm ready to connect to the internet, the part of the network that has to have global addresses, I can just assign those. So it's much easier to work with. Now, I didn't have to write the software to do this. Actually, is a little website that does this for you. I put in the MAC address of my computer. Here, my computer I'm on right now, it read the time from its own local time and generated a prefix for me. So I have now created a prefix, FDDB F808 7418. That's 48 bits, and that should be unique in the world with very high probability. If I compare this to any one other network that uses these ULAs, the chance that I'll find the same prefix somewhere else is quite small. Not that I care, because this network is totally isolated, but there we are. So now I'm going to try to use this prefix, and I put this in a notepad so I can more easily copy it, because I'm going to need this quite often. All right, so let me hop into my simulation here. First thing I'm going to do is just put this here, so I put another label here so I know. Whoops. I can't type. But then you guys know that. I've never been able to ever type. And it didn't take the F, but I can do that. There we go. Right, so let me recopy that, because I apparently did not copy that correctly. There we go. All right. So let me go into Let's see. Go to VyOS number 5. And one things that from my reading of the various standards documents, RFCs, one thing that I believe to be correct, but I do not know, is that I can on what are effectively point-to-point links. I don't expect this link from 4 to 5. It's just connecting number 4 to number 5, and I'm on number 5 right now. I do not expect anything else is going to be on that link. The only purpose of that is connect those two routers. All right. In that case, this is, I think, the one exception. I'm, in theory, allowed to use a /127 prefix. So I basically just use the 128th, the single bit, to identify the two devices. So that'd be my first attempt here. So I've never done this before, so we'll see what happens. I'm going to try to give this, make this this link here and I'll pick, I'll have to pick some. I'll have to pick a prefix, a 127-bit prefix, and I think I know how to do that. it is a little on the tricky side. So let me see if I can make this work and see what we need to do. Now, interestingly enough, when you set interface addresses, the VyOS VyOS operating system I think. I'm sorry, I wasn't paying attention to chat here. Y3. So the most at the time of the writing of that that standards document, the example that was quoted most often was corporate mergers. Right, so I have two data centers that belong to two different companies. One company buys the other, or a company buys both, and you now create a combined corporate network. And these are not theoretical instances, right? If you do that today in the IPv4 world, you almost invariably run into having to renumber the devices in one network or the other, because both people pick 10.0.0. 10.0.0 and 10.0.1 and 10.0.2 as their networks, and you can't, you have to renumber one or the other. We've even run into this at the university, because we were using a net 10 block inside our data center and we were using that before the university ever started using basically carrier grade NAT extensively. When they started doing that, they realized that they had to block out a couple of subnets because we were already using them, and it would have created a problem. So it's not theoretical. And then again, in my what I threw out earlier is that even within a single company, you could have a couple different cloud service instances that started out as completely separate applications, and then suddenly someone realized it would be nice to have them merged because of combining functionality, whatever. You would run into the same problem, because again, people will pick the addresses that are easy, and that means that most likely everybody will pick the ones with low numbers or so in fact the RFC we just looked at specifically prohibits using hand-assigned simple numbers, and if you need more than one prefix for some reason, you cannot simply take the prefix you generate and add one to it or something like that. I'm not sure what is best practice for IPv6, to be honest, just because their general deployment is kind of lagging behind. Um, the there are uh, I think where these non-routable and non-routable is a little bit different here, right? The RFC 1918 addresses you really cannot allow outside your organization because they immediately collide with someone else's use. These ones, because they are in theory almost unique, you can route a little bit further. I certainly can use, I can use tunnels, just like I can do that with RFC 1918 too. I can use tunnels and route them between different locations in my own organization. Um, I think where they're probably going to be used the most. I mean, I'm using them because I need a block that isn't tied to an ISP. But where they will show up the most, I think, is in industrial systems, and I'm. It wouldn't surprise me to see these things show up in vehicle systems because you could easily think about um, when you're driving, I'm not necessarily just a passenger car, but maybe a complicated, semi-self-driving truck or something. If you're driving that, a lot of components inside the truck aren't going to necessarily talk directly to the outside world, and the ones that do talk to the outside world are going to have to continually get new IP addresses because they're connecting in different ways, and so there's some logic in a design that takes isolated components and gives them these stable addresses that don't have to change. And the devices that do talk to the outside world can have addresses on both networks and do talk appropriately. So if you have a gateway that you're going to use anyway for various reasons, then you can without ever doing address translation, which is a problem. You can very easily create sort of isolated networks, especially like low-end controllers that don't have much security. It probably would make a lot of sense to do that. Because that means that there's, by definition, even when a firewall fails open, they just aren't reachable, and that's probably not a bad thing. So I think that in a lot of embedded systems and industrial applications, I suspect this actually will get some use, as well as sort of automotive and other type of again, sort of industrial systems. Actually one of the use cases for this type of addressing that was put forward when the internet drafts that were leading to these RFCs were being discussed was ships, merchant ships, even Navy vessels, cruise ships. And remember, these RFCs are like 10, 15 years old. This is prior to affordable satellite internet connections for shipboard use. And so exploration vessels was something that was put forward a lot, where when those vessels are at sea and disconnected from any network, unless they want to use very expensive satellite circuits, they will be running on these non-route these ULAs. And as soon as you get to port, you plug into the dock internet interface, and at that point, your devices that are supposed to be internet just pick up a second IP address that's routable and use that to talk to the world. But they can still talk to everything else the way things have been set up. So, there's some utility to that. All right, so. Let me see if I can create something that this router will accept. So I want to set interface Ethernet, and this is Ether0. I want to give it an address. Now this guy doesn't need it doesn't need me to tell it it's an IPv6 address because the structure of the address will make that clear. So I should be able to, if I hit tab here, And notice that that my next option here, aside from some DHCP stuff, is to give it either an IPv4 address or an IPv6 address in the appropriate format. So I'm going to try to start. Whoops. Oh, Control Shift V. There we go. So there's my prefix. I'm going to leave the subnet ID, the normal subnet ID, the next 16 bits 0 for all of these. And so the lowest number I can make is all zeros. It ends in 0. So that's what I'm going to do here with the /127. Let's see if the router accepts that. It may not, because technically these are special. These are special purpose prefixes. The prefix isn't supposed to be longer than 64, and it may enforce that. I don't know if it will or not. We're about to find out. Cool. Okay, let's see. Let me commit that. Now let's take a look at our interfaces here. Now, that doesn't mean I can use it, but it did accept it in theory and installed it as a. Now I've got to go and give the corresponding interface here on VyOS 4 the correct address that matches this guy. So let's do that. Let's see, do I have VyOS 4 open already? I do. There it is. I need to go back in configuration mode. For your guys' benefit, I need to make this bigger. That also makes it easier for me to read. All right, then this is going to be. Whoops. I hate it there. Yeah, there's 4. Okay, well. And so this will be Ether 1. So I want to do the same thing here. It's Ether 1 on router number 4. And it helpfully tells me that it has an IPv4 address. So now, what I want to do. Now, this was all zeros. This is the address we put into VyOS 5. This one, the only other address on that network is the one where the last bit is a 1. So this is should be the corresponding address. All right. So that Ether 1 now has that the address we wanted to have now. Interesting. So one of the things I was curious about on Linux, you generally have to use 2 different commands, ping and ping6, depending on which address family you're using. This router is already smart enough that it can again determine what address I'm using from the basically the format of the address. So let's see if this will work. All right, so remember the other router, the first one, number 5, that we configured. That's the address I gave it. Look at that. Don't you love it when things work? So this is an IPv6 ping. So and it looks like we're going to wrap it up here. Let me sort of give you the short version of what I have to do next to kind of fill this stuff in. We're going to do a little bit of that next stream, regardless of what else we do. So let me give you a bit of a rundown of what's going to have to happen next. So what I did here is VyOS number 4 and VyOS number 5 can now communicate over IPv6. Yes, I do, ODG. I love it when a plan comes together. So we need to repeat that process with different. Somebody bring that interface back up here. Remember when we configured this one, we used FDDB F808 7418, which is our fixed prefix, ::1, which means all zeros with 1. So the next pair of addresses will be 2 and 3, and so on. So we're going to go through the rest of this. So we've got point-to-point links here, here, and here. We're going to configure those and set them up appropriately. Now, once I have done that, my next trick is going to be to see if I can let these edge networks set themselves up with IPv6 automatically. And there's a way to do that by having the router basically tell the devices on the network that are attached to the router what the prefix is, and they can self-assign an address. But I want to see if I can make that work with these particular devices. And if I can, I will try it with an actual full Ubuntu install and see if we can get that to work. But that'll be the next step. I will do some of the sort of trivial configuration. It just sort of repeats what we just did in the interim. But that I want to play with on stream next week to see if we can get that to work. ODG, yeah, if nothing else, you're dealing with alphanumerics, which just sort of cognitively, I think we have a harder time, recognizing than pure numbers. The standards require that we use all lowercase, which for me at least makes it a little less readable. But that's a requirement of the standard, so they have to be lowercase. And it just, if nothing else, 4 times as many bits. So even compressing it a bit more in hex still makes for a very long address string. So no, then they're like you said, they're just not as easy to read just because there's so many digits and they're sort of almost seemingly random in some places. The intent is for end user never ever have to touch IPv6 addresses. You expect them to use names only. And there are ways to do that, and that are pretty efficient. All right. With that, let's kind of do our sign off here. As always, I am super grateful for anyone who was with us here live. Appreciate being here. Appreciate the conversation and chat. Regardless of whether you're here with us live or you're watching this as a VOD on Twitch, do us a favor and hit the follow button down below. We'd really appreciate that. And if you're watching this on YouTube, we would love for you to hit that like button if you would. Doesn't cost you anything. Helps us get a little bit of exposure. At least that's how the YouTube algorithm appears to work. And if you feel so inclined, hit the subscribe button. If you want to get notified when we send more stuff to YouTube, or if you want to have an easy way of finding the channel. ODG is saying, just to close out, ODG is saying at one point you could easily read hex by an octal. Yeah, if you use it every day, it's a lot easier. Hex, it just takes an octal. I've gotten so out of the habit for decades that I have a hard time. In fact, that video series I was talking about, they remind the viewers every now and then that all the numbers are octal, because that's how the That's how the diagnostic module and everything else for that Apollo guidance computer, they all used octal, not hex, which I recall being, that's very common for very early computers. So with that, we'll sign off for today. Hope you'll join us again next week. Same channel, same time. Until then, be well, and we'll see you next week, I hope. Bye-bye now.